Hello everyone, we are Team 9, and for our final presentation, we are going to review the design and construction of the stadium from the inside out. First, let's look at the foundation. Stadium in the size of the need to be the very deep foundation. Foundation pile must hit 37 meters underground, most deeply than the edge of the stadium. Engineers need to such a slow foundation to support such a large-scale heavy structure. Also, due to the structure of the bird's nest span is very big. So, for pile foundation, it's in the vertical stress as well as bigger horizontal stress. Conventional foundation piles can become unstable in this situation. Engineers decided to try out a special technique, hopes to solve this problem to improve the bearing capacity of foundation piles. The buried in piles of granite pipe. So the second day after the completion of the foundation pile, perfusion in the injected water mode to improve the bearing capacity of soil around the pile. To make the stadium foundation pile bearing capacity is greatly increased. For the bowl-like structure, the engineers first divided the concrete skeleton into 3 layers to support the seating area. The first 40,700 seats of pre-made concrete slab were placed on the skeleton to form the grandstands. Next came the construction of the most important part of the bird's nest, the installation of the steel exoskeleton, a series of interlocking steel trusses, each of which supports each other, was used to surround the central concrete stand area. Since the steel construction of the stadium building is curved, the engineers used the principle of multi-point molding to make the components of our steel structure, and then assembled them after making small models. The stadium starts with 24 columns of steel, support at the base of each truss column, which is pulled by workers. So installation process is slow. Then the beam column is installed on support point. The main function is to transfer most of the weight of the building to the foundation, because the overall weight of the beam and column is about 1,000 vertical tons. So the crane at that time cannot lift the whole beam and column. So the beam and column are disintegrated into several parts by the factory processing and transportation to the site. The lifting of a piece of structure. Lifting a piece of the structure after welding work the beam and the column into one. Next is the welding work. Because the crane needs to lift the steel structure of the stadium to the sky one by one for workers to weld, and because it's a group of irregular blocks, it needs to adjust the welding position many times when welding one piece each time, which is very difficult. It's also dangerous to weld the roof of stadium because the workers have to work 70 meters above the ground. The more serious problem for the welding is the weather, due to the phenomenon of thermal expansion and the cold construction of steel bars. The welding works must be carried out at noon in winter when the temperature is the highest, and in summer when the temperature drops in the evening. And in the case of bad weather, also need to stop the construction to ensure the safety of personnel. As a great architectural work of the fourth generation stadium, without any redundant treatment, the structure is directly exposed to the outside, thus naturally forming the appearance of the building. The external looks closely intertwined and the shape is complex, but the internal has a very regular structure design. The structure of the stadium can be roughly divided into 5 parts. The first part is the steel, the new steel that holds up the bird's nest steel bars, which can withstand a magnitude 8 earthquake. The second part is the lawn. The lawn is composed of 5,000 more pieces of small glass assembly. The third part is the auditorium. The uniform ball-shaped structure will be able to minimize the interference of the seats. The fourth part is the membrane, to protect the audience from the rain and provide structural strength. The fifth part is about the track. The track surface of the stadium is uneven particles, which increase the elasticity.
When you see from the sky, the interlocking beams give the stadium its bird's nest illusion. It's a brilliant description. The impact that it has when you see it's one of very organized chaos. It's rather delightful. With this revolutionary design place unusual demands on the beams. The beams must physically twist and curve as it warps around the stadium. Before construction can begin, the team was made sure the steel is strong enough to bar the load, especially around the curved edges, where it has the most twists like a climb to the top of the building. And then they change direction. It's always the right angle, and then they cross the stadium and then curve back down again. That's over 984 feet from one end to the other, wrapped around with the same side up. At all times to the top of this structure, 230 feet in the air. It's the last piece of the puzzle to complete the steel skeleton of this unusual arena. Steel roof is 1,050 feet long and 974 feet wide, and covers a massive bowl that seats 91,000 spectators. It's the largest stadium even built in China, and it's the center of the biggest sporting event in Chinese history. But even more impressive vintage huge size is its unprecedented design. It's an ambitious plan that called for giant curving beams, which crisscross in an intricate pattern of woven steel. They give the building its nickname, the Bird's Nest. No building like this one has ever been attempted before in the world. They came up with a concept inspired by old Chinese art, with sweeping line arranged around the circle window, without any redundant treatment. The structure is directly exposed to the outside, thus naturally forming the appearance of the building. Right from the start, we were thinking, well, how we build this, how do we create this element? The architect's plan calls for massive beams that twist and turn around the 984-foot wide stadium. It needs to look random, to create the bird's nest illusion. But at the same time, the beams have to support each other and carry the heavy load safely so that this artistic vision can stand on its own. The first set of beams is on the outside 24 pillars in the form of trusses encircling the concrete ball. They serve as the bones of the structure. Just like a human skeleton, this backbone keeps a building from falling down. But in the case of the bird's nest, the skeleton is on the outside and is also the building facade.
Concrete structure of the stands of stadium is a special shaped foam shear wall structure formed by 12 concrete shear walls. The upper part of the foam structure supports the precast viewing platform. About 14,000 precast viewing platform and large span inclined beams constitute the spectators' stands. The bird's nest stands are like a three-dimensional ball and undulating edge around the stand's closure structure, and the upper and lower stands are partially interlaced with each other. Wherever spectators sit in the bird's nest, the view distance from the center of arena is about 140 meters, and the athletes are surrounded by their spectators as if they were actors on the stage. The structure is designed to create the best atmosphere for the competition. It's necessary to unload 78 supporting steel farms, about 14,000 tons of load, which can resist the magnitude of 8 earthquakes, can remain intact. During the construction of the stadium, 78 temporary steel columns support of the stadium. The unloading of the bird's nest steel structure is to use jacks to erect the steel structure. The working principle of the process of the unloading the supporting load provided by the 78 temporary supporting towers is the same as that of changing the tire for the car. About 14,000 tons of the load will be unloaded. When the 78 temporary supporting towers are unloaded, the support points of the steel structure will be removed by the unloading method to ensure the stable landing of the bird's nest. The unloading process is divided into 7 steps. First, the steel structure will be lifted to a suitable height. When the supporting steel farms is removed, the stadium will completely rely on its system to support and form its stress structure. On the roof, they will be laid with 2 layers of the internal and external membrane. The outer layer is an ETFE membrane, structure used to block rain and snow, which is installed above the steel structure. 12 meters below the ETFE membrane lays a second layer, PTFE membrane, suspended on the steel structure. After using this kind of film, The light in the stadium does not come in directly, but through diffuse inflection, making the light softer. The resulting diffuse light can also solve the maintenance problem of the lower-in stadium. Next, let's look building services design. The HVAC system's design had not only to meet the operational requirements of the games, but also take into consideration the need for optimum service for the post-Olympics commercial operation of the stadium. As a leisure center for the public, with a part of the area also to accommodate a hotel. To fully embody the Green Olympics, concept, operate, new techniques, and equipment were to be adopted for energy utilization. The thermal properties of the building envelop the indoor environment, energy efficiency, and environmental protection, all coming together to ensure sustainable development. For Summer Olympics, the cooling system is very important, in addition to the main chiller plant and the ice storage preservation. A ground source chiller system was designed to meet particle cooling load requirements during the Olympics, and provide the cooling source for the interior rooms. In post-Olympics commercial operation mode during winter and the spring and the autumn transition season, when the cooling load is not significant as a baseload unit for the ice storage system, making full use of renewable energy source. This design concept embraced the Green Olympics philosophy. Next is lighting.
Accent lighting for the interior columns would also enliven the space, as well as add to the overall external silhouette lighting. Very narrow beam spotlights would be mounted on the columns at various heights to accentuate the outer surface of these columns. Also important is creating the overall image of the statue is the wash of light over the outside surface of the right statue ball. An even wash of saturated red light on the ball surface was proposed, using a symmetric floodlight fixture mounted at key locations around the ball. The final element in creating the external silhouette effect, as well as enhancing the brightness and ambience of the interior of the concourse spaces, is the wall washing of the vertical surfaces. All surfaces of the course and the glassboard that face out of the stadium were proposed to be lit by a regular series of linear wall wash fixtures. The area immediately surrounding is lit primarily by spotlight from the stadium itself, and the team made analytical design studies to quantify this light and ensure that sufficient levels would be achieved. Beyond the security perimeter, long-level path lighting is used. These are custom-designed lanterns mounted at regular spacing along the path. Additional functional lighting was developed for the security control points and feature lighting for the vegetation around the landscape. Lighting also advised on the natural lighting performance of the stadium roof, focusing on two areas: the field itself and the spectator experience. Several daylight studies were carried out to ensure that the grass received sufficient daylight to grow and that sharp shadow from sunlight on the field are minimized. In addition, work was carried out on the selection of the roof cladding materials to ensure that the spectators benefit from the daylight also, and to optimize the visibility of the roof structure above the arena ceiling by day. Once again, to realize the architectural aspiration.
The stadium started life as an iconic design concept. To ensure a lasting legacy with the widest possible range of use, it has been transformed on. Massive scale components have been added, reused, recycled, and enhanced, creating the world-class venue. While the parts and the facilities have grown rounded, the stadium has been evolving to inside and out. There's now hospitality in the west stand with service for spectators surrounding the building like a halo. A new flexible seating system has been created to give spectators the ultimate experience for a range of events including athletics, huge rock concerts, and bring fans closer to the pitch. The new roof is twice the size, now covering every state and delivering an atmosphere bigger and more intense than before. With the iconic lighting towers, reintegrated inspiring memories of Olympic glory. Innovations in design and engineering have transformed the former Olympic Stadium into a cutting-edge venue, delivering a legacy that began with the Games. Advanced energy-saving design and environmental protection measures are adopted in the construction of the national stadium, such as a good natural ventilation and natural lighting, comprehensive recovery of rainwater, utilization of renewable geothermal energy, application of solar photovoltaic power generation technology, etc. Many advanced green environmental protection measures make the National Stadium a large green building worthy of the name.